Hey guys, this is going to be the video answer key for the final review day 2 on exponential functions and modeling. All right, so the first question here, you want to write an equation in the form y equals ab to the x, or a standard exponential function that passes through these two coordinates. Well, to make this a little bit easier, you'll always be given the y-intercept. So basically right there, that tells you that a is going to be -3, that initial value. Then you'll be given a second point. The second point gives you an x value and a y value. So using this equation right here, we can substitute in. All right, so y, I'm going to pick my -17.28 equals a, which we know is -3, times b, which is what we're solving for. I don't know what that is, to the x, which is 2. Okay, so now it's just a matter of solving this equation. I'm going to go through kind of quickly here with the algebra. I can't show you the calculator, unfortunately, but I'm going to divide both sides by -3, and that gives me 5.76. And that's going to be b squared. And I'm going to take the square root of both sides. Now, it doesn't say what to round to, so I'll just go to the nearest tenth. Actually, I think it comes out to a tenth. So b is 2.4. Now, it wants us to write the exponential equation. So now I'm just going to say y equals a, which is -3, times b, which is 2.4, to the x. And we've got our final answer. Question 2 wants us to find the half-life of an isotope if we know it decays continuously, so that's going to be a keyword right there, from 5 to 4. You can use your half-life formula here. I'm going to use PERT. I see that word continuously here, and I think this is maybe a little bit easier than remembering a separate formula. So what do we know? It decays from 5 to 4. So my initial value is 5 milligrams. It's going to decay to 4. All right. E is E. The rate, I don't know. But I do know it takes 12,000 years. So my T is 12,000, and I'm going to be solving for R. All right. So to solve this equation, we're going to divide both sides by 5. So that's going to give me 0.8 equals E to the 12,000 R. Now what we need to do is take the natural log of both sides. Because remember, I want to isolate that exponent. So when I do that, this exponent here comes out front, if you remember. Okay, so now I'm going to have natural log of 0.8 equals 12,000 R natural log of E. Nice thing about this is the natural log of E is just 1, so that kind of goes away. And all I need to do now is divide by 12,000. Now, I'm going to write this out as a decimal. It's an extremely small decimal. Ideally, you'd probably want to just use this expression because now I need to use that in the formula. But like I said, for practical purposes, I'm just going to write this out. I got -0.00018,595. Obviously, this is a very small number. You need to use all of these decimals. When I have to do a calculation again, I'm just going to keep this information in my calculator. So now I want to find the half-life. Well, let's use this formula again. Half-life means half of the substance is remaining. So if I start with this, half of that is 2.5. So I need to know to put 2.5 right here. That's going to be 5. E to the R, which is -0.00018,595. And I'm solving for T. That's going to be the half-life. So now I'm going to divide both sides by 5. That's obviously going to give me 0.5. There's your half-life. E to the -0.00018,595T. And just like the other side, I'm going to take the natural log of both sides now. The solution is exactly the same. Numbers are different. So this is going to give me a natural log of 0.5 equals this very small decimal times T times natural log of E. And as we said before, the natural log of E is just 1. And so now I just have to divide by that decimal. So basically, T equals natural log of 0.5 divided by -0.00018,595. And I'm just going to round this to the nearest year. I got 37,275 years. So again, if you're off by a few years, probably you didn't keep enough information in the calculator. Please remember to write this out to many places, or better yet, probably use this in its place. Okay, question 3. All right, so we've got a population of 50 Amur leopards introduced into the jungle in 2009. The population is expected to grow by the function p of t equals 50 e to the 0.035 t, where t is in years after 2009. What will be the population in 2020? All right, so in 2020, t is going to be 11. So basically, I just need to plug in 11 to that formula. So for part A, I'm finding p of 11. That's going to be 50 e to the 0.035 times 11. Let me throw that into the calculator. I got 73. Okay, again, we're talking about leopards here, so you just want to round the answer. It doesn't say one way or the other, so this is obviously an estimation. Part B, it says how many years will it take for the population to double? So when I see population double, that means p of t has got to be twice the initial amount. So that means that's going to be 100. All right, so that's going to be 100 equals 50 e to the 0.035 t. And I'm going to be solving for t. So we've already done a couple equations like this. I'm going to divide by 50, so that's 2, which makes sense because it's got a double, right? E to the 0.035 t. And again, I'm just going to go through quickly. We just did this on the last problem. Take the natural log of both sides. This goes out front. So basically, I'm going to do a little bit here in my head. Let me switch that up. T equals natural log of 2 divided by 0.035. How many years? I got 19.8. It doesn't say what to round to. It doesn't say in what year. It says how many years. 19.8 years. Question 4 gives us 3 scenarios, and it wants to know which investment provides the greatest rate of return. So 3 separate calculations. For part A, we've got a $975 deposit, a yearly rate of 2.1%, and it's compounded monthly for 10 years. So one thing I notice here is time is the same in all 3. So I need to use my compound interest formula. All right, so for part A, I'll just write down the formula one time. P times 1 plus R over N times, or to the NT. And let's just plug in the numbers we have. All right, so my end amount, my principal initial amount, 975, 1 plus. My rate, 2.1% is 0.021 is a rate, divided by the number of times it's compounded. So if it's monthly, N is 12. So that's going to be 12 there. This is also N, that's going to be 12, and it's for 10 years. So we're simply going to throw it in the calculator in one shot, and let's round to near a cent. I got $12,002.61. Now, that doesn't give me a rate of return, remember. It says rate of return. So what I need to do now is see what percent increase that is over the original. So the way we do that is we take our end amount, subtract our original amount, and divide that by our original amount. And that's going to be 0.2335. So that's the rate of return on that particular investment. So part B. I also have compounded, this is daily, so for this one, N is going to be 365. Same compound interest formula. I deposit $950 though, so this is a little bit different. So that's going to be $950. 1 plus this rate is 2.15%, so it's 0.0215 divided by 365. I have to raise that to the 365 times 10. Okay, so again, I'm going to throw that into the calculator, and I got $1,177.86. So to get my rate of return, I'm going to take that value, subtract the original, divide it by the original. So that was 0.2399. So there's that rate. And finally, for C, we have a $945 deposit, a yearly rate of 2.3%, but this is compounded continuously. So we're using our PERT formula here. I'm not going to write it out again. We just did it on a previous problem, but this is going to be 945. E to the R is 0.023, and it's also 10 years. So if I put that into the calculator, I got 1189.38. And to get this rate of return, I'm going to take that value, subtract the original, divide by the original, and that's going to equal what I get, 2586. So now, if you look at your three rates of return, which one is the greatest? Obviously, it's going to be this one, so I'm going to say choice C. And all my work is illustrated there. Question 5 gives us an exponential function and wants us to find the horizontal asymptote, the average rate of change, and then the inverse. Okay, so horizontal asymptote. When you see horizontal asymptote, I need you to think of limit as t, in this case, approaches infinity. So limit to infinity when you hear horizontal asymptote. So let's do that. I want the limit as t approaches infinity of 100 over e to the 0.15 t plus 72. Now notice how I wrote this, 100 over e to the 0.15 t, because this exponent here is negative. Whenever I do limits to infinity, I want rational expressions. So what I can do here is utilize some properties of limits and take the limit as t approaches infinity of 100 over e to the 0.15 t plus the limit as t approaches infinity of 72. Now, if you remember back to our limit unit, I've got basically here, if I plug in infinity to t, I'm going to have 100 over infinity. So that's going to be 0. The limit as t approaches infinity of 72, it doesn't matter what t is in this case, it's just going to stay 72. So my limit is going to be 72. So if I want the equation of the horizontal asymptote, I have to use my function notation. That's going to be c of t equals 72. Now this part of the question, explain whether or not this asymptote is realistic in this context. Well, we're talking about a cup of hot tea, t minutes after it's poured. So basically it's cooling down, all right? So 72 represents the room temperature. The asymptote says it's going to approach 72 but never get there. Is that realistic? Well, not really, because the cup of tea will eventually be 72 degrees Fahrenheit. Okay, so now part B. Let me switch colors here. Part B wants the average rate of change. Well, that's something we haven't done a lot of. You did it in Algebra 1, but average rate of change. Okay, now notice here, this is important too, from 4 to 10. So basically, if you remember your average rate of change formula, I need to calculate the value of the function at 10, so c of 10, subtract the value of the function at 4, and divide that by 10 minus 4. Now again, unfortunately, I can't show you my calculator, so if I just plug 10 in here and then 4 in there and evaluate this expression, here's what I got. So c of 10, I got 94.313. C of 4, I got 126.881, which makes sense, right? Because the longer the cup of coffee is sitting, the cooler it should be. So this number should be smaller. And divide that by 6. And I got negative 7.1 degrees Fahrenheit per minute. And we have to be careful here because notice they want us to include units. They want us to be specific. All right, now part C, the last part, the inverse. So we've done an inverse before. Remember, we like to switch x and y. So I'm going to replace my function notation, just use simple x and y. That's going to be x equals 100 e to the negative 0.15 y plus 72. So I did this. I switched those two from the original. Now I need to solve for that. So I'm going to subtract 72 from both sides. That gives me x minus 72 equals 100 e to the negative 0.15 y. Divide by 100. Scroll up a little bit here. So x minus 72 divided by 100 equals e to negative 0.15y. And I'm just going to take the natural log of both sides. Okay, so that gives me, this is going to come out in front, remember? So I'll just write that over here, 0.15y equals natural log x minus 72 over 100. And lastly, I'm going to divide everything by negative 0.15. Okay, so this is going to be the inverse of the function. I just need to make sure now I use the appropriate notation. So let's go back up. It's m equals c inverse of t. Okay, so let's use that. M equals c inverse of t equals natural log t minus 72 over 100 and all of that over negative 0.15. Question number 6 talks about the decrease in the population of gray wolves over the past 21 years. Part A wants us to find out how many wolves are there now, so that would be in 2020. So basically all you need to do is subtract, 1999. I mean, it tells you in the problem too, that's going to be 21. And anytime you're talking about population growth or decay, I'm a big fan of using the PERT formula because that is something that happens continuously. It doesn't happen just like once a year. So for part A, I want to use that formula, find out how many wolves there are. My initial amount is this 8,600 in 1999. E, my rate, and this is kind of challenging sometimes when I talk about the decrease. Remember, when using your PERT formula, a decrease would indicate a negative exponent. So that's going to be negative 0.125, and my time is 21. So you want to put that into the calculator and round to the nearest whole number because you're talking about wolves, obviously. And we got 623. Okay, so part B. It says, what is the annual percent increase in wolves over that time span to the nearest tenth of a percent? So for this, what we need to do is we need to model this after our basic exponential function. All right, so that's like a y equals ab to the x. And this represents either 1 plus your percent increase, or if it's a decrease situation, it represents 1 minus the percent decrease. So if I want to find the percent decrease, I got to get this formula to look like y equals ab to the x. So basically what I need to do is I need to bring everything inside my b term other than t, or your exponent. So this is going to be e to the negative 0.125, and I'll leave my exponent on the outside. So I'll just call that t. Okay, so now I'm going to evaluate e to the negative 0.125, and I got 0.88249. Okay, so now how do I get a percent decrease from that? So what I need to do now is I need to take, there's a couple ways you can do it. You can take 1 minus 0.88249, okay, and that gives you 0.1175. So you can say it's a 11.8% decrease, or if you don't like using decrease, you could just say negative 11.8%. But I prefer that one. Okay, so part C, it wants you to write a function that models this scenario. What does it say? It just says write a function. Okay, so this is pretty straightforward. C of t, w equals c of t. So my initial amount is 8,600. And there's a couple ways you can do it. We found that rate of 0.1175. So if you wanted to write it like this, you could do 0.1175 and then to the t. This would be acceptable. Or if you want to use the PERT formula, which is the same formula, we just don't multiply or calculate e to the exponent. That's going to be 8,600. And it's going to be times e to the negative 0.125 t. All right, so either one of those is acceptable. Okay, finally, D. So part D, if this trend remains constant, during what year will the number of wolves reach 1/4 of the 1999 level? So for this 1/4, we're going to take 8,600, divide by 4, and that's going to be 2150. Okay, so let's do this. 2150 equals 8600 e to negative 0.125t. So again, I'm going to divide by 8600. That's going to be 1/4, so that's going to be 0.25. Some of you can go right to this step if you know what you're going to end up there anyway. And now I'm going to take the natural log of both sides, which we've seen many times already on this review. So basically this exponent goes out in front. I get negative 0.125t equals natural log of 0.25, and I just divide by negative 0.125. So in doing that, for t, I got 11.1. Now, if you notice in this question, it does specify what year. During what year? It doesn't say in how many years, during what year. So now what I need to do is I need to take the initial year, 1999, and add 11. I don't care if it's 11.1 or 11.9. It's still in that 11th year from 1999. So obviously that's going to be 2010. Question number 7 wants you to create an exponential function that models this data right here. All right, very similar to one we did earlier on the review. And if you remember, I told you you'll be given the y-intercept. So if you notice here, you know A is going to be 1, 3, 2, 4. Now there's a couple models you can use. I'm going to do it both ways. You only need to do one. I'm going to use our standard y equals ab to the x. You could also use our PERT model. Okay, so if I start with this one over on the left, y equals ab to the x. This right here will be my x value. That right there will be your y value. And I know a is 1324. So I've got 986 equals a, which is 1324. I'm looking for b, and x is going to be 11. So what we're going to do here is we're going to divide both sides by 1324. And I got 0.7447 equals b to the 11th. And again, you would keep all of this information in the calculator. Don't round it and use a rounded value. And to undo an exponent, I'm not going to use a log here. I need to get rid of the exponent. I'm going to take the reciprocal exponent. So I take both sides to the 1 over 11th power. Okay, so what I get for my b value there is 0.97356. It doesn't say what to round to. It's generally a good practice in these situations to go at least 4 places. So my function, say function notation, yes, exponential function. So I'll use f of t equals my a value, which is 1324, times b, which is 0.9736 to 4 places, to the t. So there's one solution. That's 100% acceptable. If you prefer to use PERT, all right, it's going to be a similar setup. We're going to be using a natural log in this case. So my end amount is going to be 986 equals your initial amount, 1324, e to the r, which I don't know, solving for that. And t is going to be 11. All right, so now what I have to do is divide by 1324. So again, that gives me 0.7447 equals e to the 11r. And I'm going to take the natural log of both sides. Again, something we've done a lot already. And you know that exponent's going to go out in front. So what that's going to give me is natural log of 0.7447 equals 11r natural log of e. And that natural log of e becomes 1. So all you do now is divide by 11. So if I throw that into the calculator, my r value here ends up being negative 0.0268. And I want to write a function. So I'm going to use f of t notation just because that's what I used before. Equals my initial amount, 1324, e to the r, which is negative 0.0268 t. So you certainly don't need to do it both ways. I'm just showing you 2 models. Again, if you are interested in my preference, I think this one's just a little bit easier. All right, so this is something that's completely new for us. We didn't practice it during the year. We did a little bit of this in day 1 review. I don't need to decompose a function. So I'm going to give you one function, and you need to come up with 2 functions that if you compose them, right, perform the composition of them, you get the original. So the reason I put this in here is because it's just an exponential function. So for part A, I want to decompose w of x into a pair of functions, z of x and y of x. So basically, I need to end up with this. Well, what I like to do is I like to take a look at the operations I see in here. And I see a simple multiplication between the 7 and this. So what I like to do first is come up with a function, and we'll call it, I do this one first, so z of x, where I just multiply two things together, and one of them is 7. So I'm just going to call this 7x. All right, so then what I want to do next is I want to take a look at what's inside that other function. It's e to some power. So for my other function now, let's call this one, what they want, y of x. I'm going to take e to the 0.5x plus 8. So I think these are two functions that'll work. How do you know? Well, now you want to compose those two to see if it does work. So w of x equals z of y of x. So this is the same as z of y of x. Well, my y of x here is this. So that means I'm going to plug that in here. Okay, so that's e to the 0.5x plus 8. So now what I need to do is I need to figure out, well, what does z do? What does z do to this? Z is 7 times x. So it's 7 times whatever's inside there. 7 times whatever's inside here. So that's going to be 7 times e to the 0.5x plus 8. And I just want to check, let me get rid of all this stuff up here. I just want to check to make sure that is the same as my original, and it is. All right, well, the second step, it wants us to do it again. Just pick two different ones. So maybe in this case, I'm going to look at these two, and I'm going to say, oh, maybe I group this and that. So maybe for my z of x here, I'm going to take 7e to the x. All right, so then I think y of x has got to do what? Well, y of x has to incorporate this. So y of x is going to be 0.5x plus 8. Now, I think this is going to work, but again, I haven't tested this, so I want to make sure that it does. So let's go through this process again. W of x has to equal z of y of x. So the first thing I'm going to do is I'm going to take my y of x here and put it in there. So z of 0.5x plus 8. Now what I need to do is take this 0.5x plus 8 and put it into z. Well, up here I said z equals 7 times e to the x. 7 times e to the x. Well, my x is 0.5x plus 8. So again, all I need to do is compare and make sure that this is equal to the original, and it is. Question number 9 gives us an exponential function, and it wants us to calculate the average rate of change over the interval 5 to 10, and then it just wants us to write a sentence that interprets that result. So again, we're seeing this average rate of change formula. So part A, average rate of change is going to equal the value of the function, so v of 10 minus v of 5 over 10 minus 5. All right, so what I need to do first, I need to plug a 10 in here and calculate that value. All right, so again, I apologize for not being able to show the calculator, but if you plug a 10 in there, you should get 5350 minus, now I'm going to do the same thing for v of 5, plug a 5 in there. And if you do that, you get 5172.04. Divide that by 10 minus 5, which is 5. And I got 35.59, and that's going to be dollars per year. And part B, write a sentence interpreting that result. So I'm going to say something like, your investment increased in value an average of 35 $35.59 per year during years 5 through 10. It's not good enough just to say increase an average of $35.59 per year because it's only in that interval. It doesn't do that for all intervals. Question number 10 is talking about making a one-time deposit into a savings account which is compounded monthly. So we're using our compound interest formula. Time is going to be 10 years, and this is going to be the end balance. What is the annual interest rate? All right, so it says demonstrate or explain how your solution is derived. So just demonstrate, we're just going to use our formula and work backwards basically. So this formula right here, A equals P times 1 plus R over N to the NT. And our end amount is this, 1325.50. Our initial amount was our deposit, $750. 1 plus, now I'm looking for R. What is the annual interest rate? I don't know. Compounded monthly, N is 12. So that's 12, and it says 10 years, that's 10. So the goal here is to get R by itself. First thing I'm going to do is I'm going to divide both sides of the equation by 750. So if I do that, I get 1.7673 repeating, and that's equal to 1 plus R over 12 to the 120th. Now remember, I'm trying to isolate the R, so I need to get rid of this exponent. We just did one similar to this in a previous problem. I need to take both sides to the reciprocal exponent, 1 over 120. Because what that's going to do is cancel those exponents right there. So again, all this information here is in the calculator. I'm just going to raise that to the 1 over 120th power, and that is going to be 1.004757, and that's going to equal 1 plus R over 12. Now I'm going to subtract 1 from both sides, and that's just going to be 0.004757 equals R over 12. And then lastly, I'm going to multiply both sides by 12, and R is going to be 0.05708 to 5 places. Now, how's this worded? What is the annual interest rate? Now it says rate, it does not say percent. So if it just says rate, that is the rate right there. I'm going to round it to the nearest thousandth, 0.057, but it does not say percent, so we have to leave that rate. And we demonstrate how to arrive at that. All right, question 11. At the beginning of 2002, T equals 0. The video chain rental Blockbuster boasted 11,204 stores worldwide, should say. Assume the number of stores decreased by a continuous rate. So again, that's important. Decrease at a continuous rate. So to me, that indicates per. 18.4% per year since then. Part A, write an equation of a function b of t that models this decline. So part A, function b of t that models this decline. All right, our initial amount, that is 11,204. E, what is the rate? If it's declining, it's negative 0.184, and that's going to be t. So part B, it says, according to the model created in part A, during what year would 100 Blockbuster stores remain? Provide evidence to support your solution. All right, so it's going to be 100 remaining, and we're just going to use this equation we came up with up above, and we're going to solve for t. So again, we've seen this a lot. Divide by 11,204. I got 0.008925 equals e to the negative 0.184t. And we're going to take the natural log of both sides. And that's going to come out front. So that's going to give me natural log of 0.008925 equals negative 0.184. T, natural log of e, again, natural log of e is just 1. So I just need to divide by negative 0.184. Okay, so my value for t that I got in doing this, let me find it, was 25.6. Again, pay attention to the wording here. It says during what year. So it doesn't say how many years. So we're starting at 2002. So I want to find a specific year. I'm going to take 2002 and add 25. Remember, I'm not adding 26 because it's still in the 25th year. So obviously that's going to be 2027. And part C, I'll do that right here. It says, what is the annual percent rate of change? So anytime you're looking for a percent change, you want it in this form here, even if you start with per, because what you need to do is you need to find this B value, and remember that's 1 plus a percent increase or 1 minus a percent decrease. So I'm talking a decreasing situation here. So I'm going to take my original function, B of t equals 11,204, and what I'm going to do is I'm going to calculate e to the negative 0.184 and get that value. All right, so really I'm not concerned with anything other than that right there, e to the negative 0.184. Throw that into the calculator, and I got 0.83196. So that's kind of like your growth rate, or decay rate, I should say in this case. So now what I want to do is I want to take 1 minus that, and that gives me 0.1681. So now again, does it say what to round to? What is the annual percent rate of change? It doesn't say what to round to. I'll just go nearest tenth. Two ways you can express your answer. 16.8% decrease, or you can say negative 16.8%. So you can use the vocab word decrease to indicate it's declining, going down, or you can just indicate it with a negative. Our final question, and it's a doozy. It says a step drill bit is shaped like a cone and drills a round hole that increases in size. All right, so if you think about what that's going to kind of look like, it looks like this. So as you drill, the circle becomes bigger and bigger and bigger. All right, so I want to create two functions. First function here, it says the area of the circle as a function of the length of the radius, A equals CR. A equals CR. Well, we just need to know our formula for area of a circle. Area of a circle is pi r squared. So that's going to be pi times r squared. Okay, that's not too bad. So the second part here says the length of the radius of the circle as a function of the number of seconds since the drill started the hole. R equals G of S. Well, what's happening here in this situation? It says the radius of the circle as you drill is increasing at a rate of 0.75 millimeters per second. So really, I just need to increase that by 0.75 every second, or 0.75 times the number of seconds. Okay, so that's 0.75 s. I'm not a big fan of using s's because my s's look like 5s, but there's my function. So now part B. It says create a single function in simplest form, which gives the area of the hole as a function of time since the drill started. All right, so area is a function of time since the drill started. Well, I'm going to be using pi r squared. And what's happening to my r? It's increasing 0.75 every second. So that's going to be 0.75 t. All right, you could have used s here. It doesn't really matter as long as you match these two up. Okay, so now what does it say? It says use the function from part B to determine the area of the hole 15 seconds after the start of drilling. All right, so I'm going to use this. A of 15 is going to be pi times 0.75 times 15, and I have to square that. So be careful here. You're not squaring the t, you're squaring the 0.75 t. So it's very important we use those parentheses when you throw that into the calculator. It doesn't say what to round to. I'll go nearest tenth. I got 397.6 millimeters squared. Now, if you're confident in your answer, that's great. You don't have to do anything more, but if you're taking a final exam, let's say, and you want to check this, here's how you would do it. Since we know that the radius is increasing in size, 0.75 millimeters per second, and we want the area at 15 seconds. A quick check would say, well, my radius is going to be 15 times 0.75, or 11.25 millimeters at 15 seconds. So then I just plug into the area formula of the circle. Pi times 11.25 squared, and guess what? That gives you 397.6. So indeed, that does check. All right, so that finally concludes this video. Thanks for staying tuned, and good luck on the final exam.